All right, what's up everybody? In this video, I'm going to be showing you the suspension on my '69 Mustang. I've recently started putting the car back together after having replaced the frame rail, the torque box, and the shock tower on the driver's side. My father and I did that, and he did all the welding. It turned out pretty nice, so I just now have put the suspension on both sides, and I'm going to show you what that looks like. So in this video, I'm going to talk about the upgrades that I've made to the suspension and how it all goes together. Okay, so here's a quick rundown of everything that you see here. I reused the stock upper control arm and have just painted it, replaced the ball joint. I have the control arms dropped 1 inch. It's been that way since I did that in the 90s. So I've reused the spring. The spring rate is a 600 pound per inch spring. I think it's an IBAC spring. I have put in a roller spring perch there from Open Tracker Racing. Also on the lower control arm, I have a Global West lower control arm with a spherical inner bushing. And I've also put in an adjustable strut rod that you see there from Street or Track. Additionally, I have changed the spindle from a 69 spindle to a 70 spindle, which has a larger diameter shaft, so it's stronger. And I've painted that. The brakes are the stock single piston caliper type disc brakes, and I think that's about it. One other thing, I have put in a Cobra Automotive cross member, which ties in the lower control arms with the cross member. I don't know if you can see that, but that's pretty much it. The only other suspension piece is the sway bar. I have a 1 1/8 inch diameter sway bar, which I'll be putting in, but I think I'll wait till I put the engine in to do that. But yeah, if you want to stick around and see how I assembled all this. And down in the description is a timeline that you can use to skip forward to any particular part of the video that you might be interested in. Also in the description, I'll include a list of parts that I've used in this video. I am starting to reassemble the suspension on the '69 Mustang, and I have here my refurbed, basically repainted control arm that's still in pretty good condition. I think this is a 30-something-year-old stock replacement control arm. It's in pretty good shape. It moves pretty freely, no binding and no slop, and looks almost as good as a Scott Drake. Also have the negative wedge kit going back on from Pro Motorsports Engineering, going back to the 90s here. So, and I have a new upper ball joint, Moog upper ball joint, and an Open Tracker roller spring perch. All right, for lower control arms, I'll be using a Global West suspension lower control arm. That's really just a modified Moog control arm. If you search the part number right there, you'll find that it's a Moog part number. And what they've done is replace the rubber bushing in the back. They welded in a sleeve and installed this solid bearing, or I guess you would call it a spherical bearing. And on the underside, they've reinforced it with a steel plate that should make it stiffer. But other than that, it's just a stock replacement Moog control arm. All right, so here is show you what the bearing movement looks like with this spherical bearing on the lower control arm. This is the bolt that would normally secure to the frame. So you can see it's pretty free to move. There's the original control arm. You can see how it's just a metal sleeve with a rubber bushing that doesn't, I guess it allows it to flex somewhat, but not nearly as much range of motion. I'm going to show you the difference in size for Mustang spindles for 68 and 69 disc brake spindle and a 70 to 73 disc brake spindle. The 68-69 spindle is on the right, is from my 69 Mustang, and on the left is a 70 spindle that I picked up. I have the suspension apart on my Mustang, so I decided to change and go to the thicker spindle for this 70 to 73. So I picked up a set of 70 disc brake spindles. And so the bearing size, there's two bearings are larger on the 70. The shaft is larger diameter. So you can see the 69 spindle is 1¼ inch diameter on the inner bearing. Outer bearing on the 69 spindle is 3/4 inch. And on the 70, that's 1.37, almost 1.38. So that's about 1 3/8 inch on the inner bearing diameter. And the outer bearing is 0.86 or so, so that's almost 7/8. So they increased the journal diameter on both spindles by about 1/8 inch on the inner and outer. And then, of course, the thread size here on the end for your lock nut is larger as well. And so you have to pick up a new set of new lock nut. So you need new bearings, inner and outer, new lock nut. Also, the tie rod end size is larger here on the 70. Probably you can't tell from just looking at it, but you'll need new tie rod ends as well. So the bearings, the races get knocked into your rotor. So this is my old rotor that I'm going to reuse, and I'm going to knock the bearings out. So this is the outer bearing. And the inner bearing, and there's also a dust seal. So the bearing part numbers, so you can get your bearings from your favorite bearing manufacturer. These are AutoZone Duralast, but if you get a Timken, I believe the bearing size is like a standard size. You want a 12 and a 13 for your inner and outer bearings. And then the dust seal number is a 6815. And for the tie rod, it is the outer tie rod that is larger. And there's the part number Moog ES387R. Okay, one last thing, the casting numbers. If you want to see the casting number, this is the 70 spindle. And it is D0ZA on the 70 spindle. If you had a 71 through 73, it would be a D1ZA, I believe. And the 69 spindle that I have here, it's pretty much illegible. It's a C80A. I believe that's what that says. So there you have it. I'm going to come over here to the passenger side and show you a before shot, and then I'm going to pretty much do what I did on the driver's side to the passenger side. So I'll be back in a bit. All right, I'm going to be installing a adjustable strut rod. This is from Street or Track. I'm going to be installing this on my 69 Mustang. And so the first thing to do is to remove the old strut rod. I've already got my suspension apart. And before I take the old strut rod off, I should measure the distance of this lower control arm to a reference point on the frame, so that when I install the new one, I have a good starting point. And so I'm using the grease nipple there, measuring up to the frame, that rear frame, or that rear bolt. I believe that's for bumper support. And it's about 13.5 inches to there. So note that for later. I need to remove the rubber bushings here on the front of the strut rod, and the socket size is a 1 inch. At the other end of the strut rod, I need to remove these bolts. And first need to remove those cotter pins. And these bolts are 3/4 inch. You're going to need a wrench on top and bottom to keep it from spinning. Alright, so a few bangs with a hammer, and I got it to separate. Both bolts came out. So I'm going to be actually changing the lower control arm, putting a Global West suspension lower control arm on, and then I'll get back to the changing out the strut rod, or I will finish taking it off first. All right, the strut rod was a little stuck up there and the rubber bushing was holding it, so the solution was this. So a couple good whacks with that. I've already loosened it up, and that did the trick. All right, and the lower control arm came out without too much coaxing. Pretty much just remove the bolt, the cross bolt that holds it in there. Also adjust the camber and wiggle it back and forth, and it fell right out. I'm going to put the new one in, which is a Global West. It's a modified Moog control arm, and they've put in a spherical bushing in the end compared to the rubber bushing there. And I think this is going to be harder to get in just because the ends of this are totally flat, whereas this bushing is more rounded. So try to get that in there and be back in a minute. All right, so this is turning out to be more difficult than I thought. I've already done the driver's side, as you can see over there, and that was tight enough fit, but I was able to manage to jack it in there, which is what I'm trying to do now. But this one is a little bit tighter, and part of the problem is that the bushing is wider than the stock bushing. It's about 7/100ths of an inch wider. Plus, as I mentioned earlier, the sides of the bushing are totally flat, whereas the stock bushing is rounded. So I'm going to try to jack this up. I've got it started. I'm going to try to force it up in there. And maybe you can see right there what I'm looking at as far as the tightness of the fit. All right, that did it. I got it up most of the way in there. I just have to use something else to wedge it and to get the holes lined up there. So keep working on it. And so I used my spring. The spring that's going back in there is just a place to hold the other end, but yeah, still working on it. And there it is. I used a 2x4 turned sideways to wedge it up in there. And just like that, I've got the bolt in. Other side. All right, parts again. This goes on the lower control arm, same as the original. You've got two bolts that pass through the top. There are the two bolts with the nuts that come on the bottom. And this connecting rod, it's tubular, hollow, threaded on each end. One end is threaded with a right-handed thread, the other end is threaded with a left-handed thread. That allows you to do your adjustment by threading it in or out. Will push the lower control arm back or pull it forward to set your caster, and then the front piece that goes through the hole in the front of your frame, where I took the piece off in the beginning, the original strut rod. And so this rod end here is solid, and it's got a spherical bushing there. You can see that should be a big improvement over the rubber bushings on the original. And then just this big fat washer that goes on the end with the nut to retain it. So let's put it all together. All right, nut or bolt with a washer, and then a washer on the bottom underneath the nut. Just like that. All right, so I've got these in here just lightly tightened for a couple turns with the nuts on the bottom. I think I'm going to have to take this back out to shift it towards the rear in order to get this connected up here in the front. But you can see that's how it threads on. All right, big nut here is 15/16. These are 3/4. So I'm I'm going to thread the rod starting on this end. This end is right-handed thread. You can see how much thread I've got there. The instructions say to have 15/16 inch of thread engagement on each end. 15/16 is a little bit strange measurement, but so I'm going to start here. And as you tightened it, all right, so I've got this end started. They're both about equally threaded. And as you tighten it, rotating it this direction, so it's going counterclockwise up top, clockwise down the bottom, it will pull the threads in. You'll see the threads disappear on both ends. On the front end, the rod end is going to want to spin, so I've got a 9/16 inch wrench to grab on the flats of the rod end to keep it from rotating when I hit some resistance. All right, so I've got the jam nut tightened up on the front end and the back end. Here's kind of what it looks like, and I just need to get the rest of the suspension in order. I need to tighten up these bolts. All right, so I have tightened those bolts to spec. The specs are in the instructions, and they are, well, the specs are various for the different years of lower control arms, but let's just say I have everything tightened to spec. I have tightened the front nut, and it's pretty neat with the joint there on the lower control arm, the low friction joint there, and the rod end on the front, that the lower control arm assembly pretty much just functions as a modern control arm that's been triangulated, this piece here with the lower control arm, and there's hardly any friction whatsoever, and you can just pretty much falls down. All right, so when you put this front piece in, you want to make sure this opening here is parallel to the ground, and torque on the front nut is 110 pound-feet. Torque on these 3/4 inch bolt heads is 70 pound-feet, and the jam nuts are 60 each. And alignment specs are recommended, are right there. So there's what it looks like for final assembly. I still need to put the spring perch in, the spring shock. Here is the disc brake spindle that I've cleaned up and painted. I have it bolted to the upper control arm and the lower control arm, and I'm going to put the rotor on. First I'll need to put the backing plate on. Also need to put the shock absorber in. I am reusing these old Coney shocks that I've had on the car since the early 90s. You can see the date code right there. It looks like 1992, and they still function like new. Here's the old rotor that I'm reusing that I've cleaned up and painted. I've also installed the new races for the larger wheel bearings. Caliper bracket. One you just lit.